Today's presenting sponsor is Datadog. If your business is being driven by software, you know today's applications are more complex than ever. They're sitting on multiple layers of infrastructure and distributed services, and it can be very complicated to manage. Datadog brings visibility into every part of your infrastructure, as well as APM monitoring for your application's performance. Customizable dashboards, collaboration tools, and alerts let you develop your own workflow for observability and incident response. And Datadog integrates seamlessly with all of your apps and systems, from Amazon Web Services to Kubernetes to MySQL, so you can get visibility in minutes. You want to get started now? Go to datadog.com/cloudcast to get started with Datadog and get a free t-shirt. Datadog is trusted by thousands of enterprises. So if you haven't tried Datadog at your company or on your side project, go to datadog.com/cloudcast to try it out and get a free t-shirt. And now, on with the show.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast, coming to you live from the massive studios here in Raleigh, North Carolina. You know, folks, we talk about a lot of different things, and at the end of the day, it's always important sometimes to come back to the basics, which is, people are trying to build applications. They want to get them into production very quickly. And when they're in production, they want them to run. They want them to run seamlessly. They don't want to hear complaints from people about either, poor performance or unavailability. And so it's important for us sometimes to come back to operations, looking at operations, but more importantly, looking at kind of the evolution of operations. What does that mean from an infrastructure perspective, from an operations perspective? And so excited to have back on the show Rob Hirschfeld, a good friend of the show. Rob, welcome back.
Brian, thank you. I'm excited to be back. It's my favorite podcast. So excellent.
Well, you and I, we were together. We were out at Interop a couple of weeks ago out in Vegas and had a really good, long sort of hallway conversation. And we thought we would bring a little bit of that to the show and dive into, not only some of those topics. We want to dive into SRE, kind of the SRE overlap with DevOps, all those things, but also get a sense of what you're working on these days, because it's been a little while. So why don't we start with this new concept, and it's maybe not a new concept in general, but maybe for this podcast, this idea of SRE or site reliability engineering. Like, give folks the basics, because you've been talking about it a lot. What is it? What does it mean? And maybe where did it evolve from?
Boy, it's a fun topic to talk about, because it was one of those things that I felt like I've been doing SRE work, site reliability engineering, for my whole career. And Google wrote this book that sort of popped into the norms, defining how they run their infrastructure. And I'm like, wow, that means exactly what I do. And then it all got confusing after that, of course. But SRE has been around for a long time as a site reliability engineering track. There's conferences for it. It's something that's pretty well established, but had been really established, meaning keeping a website running, logging and monitoring and performance checking. And Google sort of pulled that concept because obviously they want to keep their site moving, but they took this very DevOps-y system-level thinking approach to it and went all the way down to the silicon and said, how do we change our site reliability, looking at the whole system from our data centers, our power structure, right? How we build machines, how we operate them, how we install data centers, the whole gamut all the way through to the user experience. And that is where, to me, site reliability really changed. They changed the definition of how people have been talking about it in a way that really resonates with DevOps teams, but is different than what DevOps sort of says. It's aligned and different at the same time.
Okay, so let's sort of break down the basics of it then. So what are the core principles of SRE, and then maybe where do they differ from maybe the kind of the core principles of DevOps?
So core principles, they're totally the same, which is what's awesome. The thing that is different is that DevOps communities really work hard on culture and process and cross-team integration and breaking down silos, all these wonderful lean process concepts. SRE is really a job function that's focused on operations and automation around those operations. So it's more like, if you want to think about the factory floor and running the factory, SREs are like running the factory, where DevOps is really saying, you know what, our developers and our operators need to work together, and they need to design things so that you go from desktop and concept all the way through to production in a continuous cycle. That's very DevOpsy. SRE loves that idea, but like you had said at the opening, that stuff just needs to run. Developers don't want to be, shoveling coal into the engine to make sure that the Kubernetes platform is running and the operating systems are patched and the load balancer is right and the firewall is up to date. Those actions, which are essential to operations and essential to site reliability, right, the reliability of your infrastructure, those fall into a job domain that's site reliability engineering. And over the last over the last year, but more in the last couple months, we've really gotten to this no ops and serverless thing where developers make all that stuff go away. They don't mean make it go away so that it doesn't exist. What they're saying is make it go away from my job. Let it be somebody else's job.
Yeah.
And that's where there's this incredible synergy between DevOps and SRE, but there's also this incredible split where we're starting to say, you know what, developers shouldn't do ops jobs. It's a different mentality.
Yeah. I kind of feel like, and this is the way in my mind that I break it down, and tell me maybe where it's right or wrong. So, I feel like DevOps was sort of at the core of DevOps is this idea that there's this sort of impedance mismatch between how fast developers can build software, potentially test it, and want to throw it over the wall, right? So they've got a pace at which they move, and they've got a certain set of tools that they use, source code and Jenkins and all this stuff. And DevOps was at its core sort of saying, hey, ops isn't prepared to deal with that pace of change, and it also doesn't use those same tools. So there's not this kind of synergy and community and all that stuff. And then the SRE thing really sort of says, okay, let's assume that Dev and Ops sort of could operate at the same pace. In theory, what would operations then look like such that people aren't the bottleneck, right? How do I automate things? How do I measure what I've automated? All those sort of things that are, like you said, sort of much more about how do I kind of factory floor what this operations process looks like. Is that in the ballpark, or is there still a lot more going on there?
I really like the way you're describing that. That's actually an interesting segue for me to give some background on what I'm doing and why we're doing it.
Yeah.
We see a crisis, and I don't mean to I don't want to downplay it. It actually is a crisis. I had a blog post in November about described as this operation tsunami of technical debt coming down the pipeline, where operations hasn't seen the degree of innovation, the degree of automation, the degree of uniformity that is required for us to stop manually automating process, right? When we see, so my company RackN runs an open source project called Digital Rebar that's designed to create site-to-site automation, right? So we believe that operators need to find ways to have much more repeatable processes, not just within their own sites, but site to site, so that they can show up in an operations meetup and actually share learnings, share process, share repeatable actions on their own process. Because otherwise, we're just going to run everything into a SaaS and it'll become a black box. Mm-hmm. And I don't think that's where things should go. I think it's an important intermediate. But we should be able to create operational best practices that work site to site, company to company. In some ways, that's where it's not in some ways. In many ways, I feel like that's where OpenStack sort of ran aground, right? We didn't end up with common operational practices around OpenStack. And so we ended up with this expensive consulting practice where a lot of people had to learn how to do it all by themselves, and what they learned they couldn't share or couldn't repeat. And now we have people running around saying the only way to run OpenStack is as a managed service, which is a failure to me of building good software. So right, and so I'm going to put down the shiny object of OpenStack for a second, but come back. What RackN has done is this software we've built decomposes operations into small units that you can then piece together, so that if somebody has Dell servers and somebody has HP and somebody has Supermicro or Lenovo or whatever brand they want, or if they're building their own servers, those changes in infrastructure don't break how you operate the infrastructure, right? You can have your own naming schemes or IP address strategies or layer 2 boundaries, all these operational needs that often break on premises and co-load infrastructure. Those changes need to be abstracted in a way that operating OpenStack or Kubernetes or Ceph or whatever cluster Mesos you want to do, those operational practices can be isolated so the software runs in a consistent way.
Yeah. And
Oof, need to take a breath.
So I feel like, we have this, so that I think one of these challenges, so people talk a lot about, I want to build software faster, I want to do these things, and there's lots of debates about, OpenStack or Kubernetes or Docker or which tools to use or all these sort of things. And I feel like if we sort of bring this back to first principles, and I think this is sort of the crisis that you're getting at is this idea of like let's put this into focus. So, if you're an infrastructure person, right? Way back in the day, you managed bare metal. Eventually, you got into virtualization. Virtualization, something like VMware would release software about once every year, and if you updated the software once a year, like you were a champion. And then OpenStack came along, and OpenStack was releasing software every 6 months as a big bundle of stuff. So, but half the sort of twice the frequency. And now you have things like, let's say, Kubernetes, or a lot of the newer infrastructure type technology coming out every 3 months. So again, this idea of doubling the pace at which the thing you have to deal with is coming out. And I feel like to a certain extent, what hasn't really happened, and I think this is the best practices you're talking about, is people haven't sort of said, like, how do I just even take care of my own house? If I'm operations, like, how do I just make sure that if I went from VMs to containers, I know how to even just update that stuff? Like, how do I upgrade it, update it, and figure out the best practices just around frequently updating infrastructure software that's a skill that people really have to get good at? Is that kind of the crux of this crisis you're talking about?
It's a big part of it. It's what I usually describe as underlay automation. So the thing that blows people's minds is that you just described this incredible acceleration we're seeing in versioning, but we're also compositing software in ways that we haven't done before. So it's not just that Kubernetes has a 3-month cycle. Kubernetes is built on Docker, which is not version aligned with Kubernetes.
Sure.
It's built on Linux, which is not version aligned. It's going to have an SDN layer, which isn't version aligned, and a storage layer that's not version aligned, and it's going to have all these components in it. So, we could sort of, connect all these things and say every 3 months we're going to make all these changes. But some of those are security patches and fixes and things like that. So when you look at, a Kubernetes cadence, you could almost say, wow, there's a weekly update path in this mix, which should make everybody's head explode. And it's not quite that bad, but I think we need to be taking a defensive posture, assuming it is. And then I didn't even touch, RAID and BIOS configurations and security postures and key rotations and the sort of the really hard things that you have to do at an operations level, multi-system, to say, oh, wait a second, I need to redistribute my digital certificates and then put new public-private key pairs all over my infrastructure on a weekly rotation basis to secure it. Oh my goodness. And I'm saying that, and if people are thinking, wow, I wouldn't even do that, or I'm not there yet, we need to get to a point from an ops perspective that type of hygiene is automatic.
Yeah. And I think that's the key point, right? It can't be, it's just like, and people will say this is a bad example, but it's just like sort of patch management, right? Whether you keep up to date with patches or not, like let's say on an OS or something, we're well past the days of somebody running around to every single box and plugging in a CD or even just there are tools that have the hygiene to do that sort of once a week, Patch Tuesday, patch management sort of style or CVE style stuff. You're getting it. We've got to be able to do that for sort of the infrastructure as a whole, and have the mindset of saying, what are those automated tools to help me make that happen?
It's has to be a system level concern and practice, and it has to be API driven. It has to become more autonomic, and it can't be done on a site by site team by team basis, right? We need to, and this is what Racken's trying to do. We're trying to help people have this conversation at the very foundational levels, and then create repeatable process over and over and over again.
Yeah. So
we can talk about what makes that really hard.
Yeah.
Or we can go other places too.
Well, let's start with let's keep this fairly simple. So you engage with somebody, and they you engage with a company, and they say, "Hey, Rob, I agree with you. It's a challenge, and we have to take on this challenge because our developers, let's say they love building their applications now with Docker and packaging them with Docker. So containers are going to be part of our world, whatever that expands to. Like, what are the first sort of basic steps that you engage, that you tell people, like, this is what you need to do, this is what you need to evaluate? Like, what's the baby steps?
And that's actually has been one of our big realizations for this, is that we had started from this idea that you needed the whole integrated suite, right, all the way up, upgrades and patches and things like that. And we found that was actually much too hard for people. They were getting indigestion trying to eat that pie. Mm-hmm. And so the baby steps for us are boot, Pixie, provision.
Okay.
And we're actually tearing apart the big digital rebar infrastructure we've built and starting back into, I just need better, what we call cloud native control. So RESTful, API driven control of my infrastructure at a fundamental boot provision stage. Because that drives into all the sorts of interesting immutable infrastructure stories where people don't even install operating systems. They just boot and install a temporary operating system. Or it just moves into these better hygiene stories. But if you don't have that base level control, everything else is harder because you're building up the stacks all the way through. And so what we've been working to do is decouple those pieces into more automatable units that you can then stack. Just like everybody, it's the same story that everybody else has, right? We're trying to find these clean boundaries. You might think, what does that have to do with physical infrastructure and booting? I don't care. But we're doing the same thing at the Kubernetes level, right? We're trying to create nice, clean boundaries between layers of infrastructure so that you can have handoffs, right? But we started with SREs. SREs are just, their job would be to run a Kubernetes infrastructure with all the storage and networking backends completely black boxed and isolated from developers, so they don't care. You have to sort of build that up in your infrastructure layer by layer.
Okay, so let's break that apart, sort of the people and process side versus the technology side. So let's say you're engaged with the company and they say, hey, we don't call our people SREs. They're that's our ops team. What are the basic sort of like, say, jobs, not necessarily titles, but like what jobs or functions that they need to say, I'm allocating this thing, right? That this has to get done. This is a job, a task that has to get done.
Boy. So I'm going to give you a parenthetical rant for a second.
Sure.
Just changing the name of your ops teams to SREs
doesn't matter.
Don't do that. No, it does matter because SREs have some very specific things that people who are like, I'm going to rebrand my ops team or my IT admins or my DevOps team as SREs. SREs include pay equity. They include development chops, automation skills. There's a whole nother conversation about that.
Okay.
That's important. So, right, if you're just renaming your ops team to be an SRE team to sound cool in all Silicon Valley, hold back because there's things that you want to accomplish in making your ops team equal in merit to your development team to create this SRE balance. Close parentheses, rant over. The things that we find are really hard is that most organizations are incredibly siloed. And so when we talk to companies that are trying to create this more automated approach and infrastructure, they typically have a networks team and they have a server admin install team, they have a operating system team, they have a Chef Puppet Ansible team, right? They have those silos get in the way of this type of automation really, really quickly. And frankly, a lot of the engagements we've had, there've been sort of this. They don't always have the title of SRE, but they have this DevOps change agent type mentality. They get brought in, they hit these siloed, fractured, operational environments, and frankly, a lot of them quit. They don't make it in the job because the antibodies to changing, I can't change my cobbler infrastructure out because we have years of crust in there, and then so we can't automate our infrastructure on top of that. That is a really hard thing to overcome because there's production systems depending on it. It's very hard to change production systems.
Yeah. Okay. So definitely something for companies to be considering is, it may not be for everybody, or it may require this idea that I've got to bring in some new types of talent to help augment and demonstrate to people.
And allow them to make change and get their job done.
Yeah. Let's flip over on the technology side. Obviously, you guys are building some tools and frameworks, but if somebody has, I don't know, let's say Ansible or something else, that they already use as something like a config management tool, they kind of think about that as their, one of their operational go-tos. Like, our current existing tools kind of still pluggable into this framework, or is this a start over type of thing?
They have to be pluggable. It was a core design requirement for us. And for anybody working with this, anybody who shows up and says, hey, throw out the tools you've got, I've got a new DSL for you, or I've got a new something, isn't really helping operators solve their problems. Because operators are running infrastructure. There's no such thing as a greenfield. Even when we were doing early OpenStack, we'd show up with new servers, but we wouldn't show up with a new IP strategy or a new naming strategy or a new out-of-band management and time and DNS. All that infrastructure still has to work. And that includes Ansible, Chef, Puppet, Salt, Bash scripts. All that is operational knowledge, and you don't want to disrupt that. You don't want to come in with a new way of doing things for people. This is actually part of my frustration on the Kubernetes side. So I'm a big fan that we need to be able to have Ansible playbooks that keep working, because they do useful stuff. Rewriting them is not a value add. If we're talking about technical debt, and I tell you to go rewrite all of your operational scripts to conform to something new, it's an undoable thing. Now, I'm not saying that all of your scripts are beautiful, pristine works of art that shouldn't be changed. What I've seen is there's a lot of technical debt accumulated in those scripts because they had to code around limitations in the system. So
sure.
There's a degree of rethinking, but not disposing.
Okay. Yeah, and it makes sense. And that sort of aligns with this idea that, to get to a better place, you're not going to, it's the old, like, you can't keep doing things the same way and expect to get a different result kind of mindset.
There's also a pathology in our industry where new and shiny equals better.
Yep.
And a good example of this to me is the Core OS, now Linux OS or whatever they're calling it. And there's a whole suite of these new lean in-memory boot operating systems, and they're really cool and they're good and they accomplish a purpose. But the reality is that you could take an existing Linux, strip it down to something simple, and use it in exactly the same way. And in that case, you actually have something operators are used to using. And so to me, we want to be careful that we don't just say, oh, this is the better way to do it, convert everything over. What we want to be able to do is find more bridges for operators.
Yeah.
Because otherwise what we're doing is we're just throwing something new at the operators. It's easy for developers, they just switch, but operators have to sustain the old, they have to bring in the new, and we're not doing a good job as an industry creating those bridges or finding the more incremental steps for implementation.
Yeah, we seem to have this fascination in our industry with showing somebody how easy it is to demo something for day one, and yet nobody ever shows a demonstration of what day 273 looks like, or something along those lines. So, yeah. The sad thing is I see those demos. I do demos, the day two demos. I wish I knew why they weren't working. Maybe people engage in Twitter. Please tell us why you think that those things aren't as compelling, and how we make a day two demo compelling. Yep. Yep.
But they fall flat.
Yep. So, you mentioned a little bit about actually. Let's talk about this other concept that we've hit on before. So, there's this new fascination with this. So you take something like Kubernetes, okay, and this has been kicking around for a couple of years, where you say, okay, so let's take something like Kubernetes. What is Kubernetes good at doing? It's good at taking a containerized application or set of containers that make up an application, and go run them in a way that you can schedule them. You can put upper and lower bounds on it. It's very good at saying, hey, if something falls down, spin it back up again. And so people are beginning to look at that and they're saying, oh, well, not only would I run my web facing application or my mobile facing application on there, maybe I should run my infrastructure like an OpenStack or something on top of Kubernetes, because, hey, OpenStack is just a piece of software that serves an application function. And we're starting to get into these sort of like layer cakes or sandwiches of stuff. Like, give me a sense of like, why is that happening, and what are the pros and cons of it?
Wow.
And keep in mind, we try and keep this podcast to a certain amount of time.
Oh, darn. So it blows people's minds, the Kubernetes sandwich, as we like to describe it, running Kubernetes first as an underlay, then running OpenStack as an application on Kubernetes, and then running Kubernetes on top of that infrastructure as a service layer. That to me gets a little bit crazy from an inception point of view. I'm a big fan of Kubernetes on Metal, but I'm also a big fan of saying the difference between virtualized infrastructure and physical infrastructure operationally should drop to zero. That's what we're trying to do from a hybrid perspective. It's not like you're running a joint infrastructure as much as you're saying, when I operate Metal, it shouldn't be any different than operating virtual machines through OpenStack or Amazon or Google or Azure or wherever. So once you sort of accept that statement, then something like Kubernetes can become a more universal underlay, which to me is very threatening to what OpenStack's message is. They've now you start having to ask, what is underlay? Where's my application targeting? I have to say, before I started all this, I thought that Kubernetes under OpenStack was a joke. I actually tried to coin the description of it as the joint OpenStack Kubernetes environment. That's how jokey I thought it was. But you're right. The idea of OpenStack just being an application is entirely right. And as soon as people start containerizing OpenStack services, which is what we're talking about, Kubernetes is a really good way to run services. And you quickly get to the point of saying, well, wait a second, maybe as an operator, I would rather run and maintain my OpenStack services using the Kubernetes platform. There's a place where this gets really hard. And it's the same place where running OpenStack on OpenStack gets really hard. If I want to run anything on Metal, I actually have to be aware of the complexity of the Metal. I have to be aware of the network and the NIC cards and the teams and bonds and where my network topology is going and how many disks I have and how they're configured. And out-of-band management. There's a whole bunch of Metal-specific stuff that you don't want to abstract away. You don't want to hide from an SRE, from an operator, because that's what makes tuning and running the system relevant. So the challenge that we're seeing is, you're entirely right, and I've become a huge fan about this. I blog about it quite a bit. I think that OpenStack should become a Kubernetes application. There's some questions around what that would take. Happy to go there. However, to make that work, because OpenStack really is a physical infrastructure abstraction, you have to be able to inject a whole bunch of information about the physical infrastructure into that topology. And that becomes a really interesting exercise, because Kubernetes doesn't have the data either by design. And so you have to have some way to say, all right, I'm about to go run my OpenStack as an application on Kubernetes, but I also need to know about my physical infrastructure, my network topology, my storage topology, and all this information has to get injected into that application so I can run it. And that's where we're playing right now. So we're actively sort of working through that process.
Yeah. So just at a real high level, to a certain extent, folks would say, well, all that physical stuff kind of it gets represented as a cloud, and so I don't really have to think about NICs and clustered, RAID and buy, and like how what's at what point should I understand the people that have to physically maintain physical boxes have to care about that, but at what point does that really have to be communicated up to an application, or do you just sort of say, give me IO and give me bandwidth or something? Like I'm trying to think of a simple way to sort of go like, where does that need to be communicated? Where does a developer have to care about that? Or how much of it's just sort of like, well, it might be nice to know?
Wow. So I'm going to give you a really unsatisfying answer.
Okay.
You want to not care at all until you find yourself having to care.
Yep. Sure.
And so what I see is, 99% of developers, and myself included, when I'm in this mode, live in happy bliss as to what the underlying infrastructure is or how it's set up. And the more we can build something like Kubernetes, where I don't care and I just say, I need to talk to this service, and that's it, that's wonderful. And Oh my God, that improves our efficiency and productivity and repeatability and portability, all these great abilities that we need to improve productivity. It's amazing.
So does this just become sort of like advancements in things like Kubernetes schedulers to be a little more aware of what the underlying infrastructure is doing for me, rather than just pods and CPU and memory?
I don't think so, because I think that you have a real danger of making the Kubernetes APIs much more complex for the 99.9% use cases. And what we're really trying to do is say, you know what, that's not the problem where Kubernetes is trying to solve. And this is where the kube on kube stuff starts. I start pushing back, and even the OpenStack on kube pieces, I'm going to push back a little bit and say, you know what, underlay is a thing. Actually managing and figuring out how to build a network interface and then hand that off to Kubernetes so you can do the install or configure it. Configuration management is still a thing as much as it's taken a back seat to 12-factor apps and automatic deployments and Helm charts, and I'm giving a very Kubernetes-focused vocabulary, but these abstraction layers are really useful for most developers. The whole idea with SREs is there's still a class of people who need to care about NIC and RAID card and network topology and IP addressing schemes and things like that, and that's okay. I'm very wary of somebody trying to embed that in base Kubernetes just for the purpose of solving this specialized problem. I saw the same problem with OpenStack. When OOO, this OpenStack on OpenStack concept surfaced way back in the Hong Kong summit, not Tokyo, Hong Kong, way back, the idea that we would expose all of this very complex physical topology into OpenStack was actually a fail to the mission of what OpenStack was supposed to do, which is hide all that stuff because most people don't care.
Yeah. No, and I think you highlight a couple things, and I think we'll sort of wrap it up on that one. It's be careful over designing for your 1% sort of 5% use case. Make sure that you're still very focused on the bulk of what you're trying to do. Try and solve challenges that hit the biggest part of what you do, and don't take your 1 or 2% use cases and make them complex for everything else. And I think the other thing that you're really kind of highlighting again with all of this stuff is, it is becoming more and more software. So, even though there are, physical disk drives and silicon and stuff somewhere underneath the covers, it's being exposed as software, it's being exposed as APIs. And at the end of the day, operations teams, infrastructure teams have to become much better software operators than anything else. And that's sort of a core skill that regardless of which technology you pick and so forth, like you've got to keep coming back to going, that's a skill we've got to foster and grow and so forth.
And that's one of the things that the SREs in the SRE book, the first 4 chapters are critical. Read those. The whole book's great, but the first 4 chapters lay out the point you just made, which is if you're an operator who's not thinking that they should be spending 50% of their time writing code and automating themselves out of a job, then you've missed this everything is software transition. And I think that's a big takeaway for people. We need to make sure that operators are freed to actually write automation that reduces the manual touch, so that they can move faster, they can accelerate.
Yep.
Because the amount of infrastructure we consume is going up, right? It's Javin's paradox,
right? From
that perspective,
right? Well, listen, I'm gonna sort of wrap it up there. I think awesome. we definitely have an opportunity to come back and talk about what some of these best practices look like, and we'll have to get you back on, because there's a whole discussion about, like, let's say Kubernetes is your infrastructure, but how much of your monitoring and alerting do you run on sort of dedicated clusters for that, and how much do you run for applications, or do you run them on top of each other, and all these stacks and layers and all that sort of stuff. So we'll have to get back into that at some point in time. Rob, what's the best way for people to sort of reach out to you, find you, what's going on with RackN, all that sort of stuff?
I am Zehicle, Zehicle, on just about everything.
Okay.
Nobody wants things that starts with Z, so that's me. So I'm Zehicle everywhere. RackN is rackn.com. It's pretty straightforward. Digital Rebar, which is the open source side of everything we do, is rebar.digital. So we have one of those cool TLDs. And that's pretty straightforward to find. And I would encourage people to check out something we just released, which is Digital Rebar Provision, which is a cobbler replacement. So it's API, RESTful, very clean, tiny Go app that basically provisions servers really, really cleanly. So cool. That's something fun to check out. It's a 30-minute at most exercise for people to play with on a MacBook.
Excellent. Very, very cool. And folks, we'll put the link to the Google SRE book, which is an O'Reilly book. We get some discounts that we can pass along to you guys for O'Reilly stuff. So if you're interested in that, take a look. We'll put it in the show notes. And for Rob and for Aaron, folks, have a good weekend, and we will talk to you soon.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.